Hello everyone, good evening. Thanks again for tuning in. This is going to be Applied Micro. I'm taking this class this semester, and these are just, again, more like reviews through the notes, just over the slides that are marked for the exams. Alright, so Applied Micro, we're going to be looking at the products used in medicine, food manufacture, and industrial applications. In the professor's notes, it says that you have a combination of all these sciences. It's a scientific discipline that deals with the application of microorganisms and using these applications in biotech, agriculture, medicine, food microbiome, and bioremediation. So the first instances, again, I'm just going to be going through the slides. They're actually marked for his exams, for the teacher's exams, and so I could listen to this back again while I'm doing something else and still get familiar with the content. Okay, so the first slide is the first products or the ancient beginnings of Applied Micro. We have bread, which was made in prehistory to about 28,000 BCE. That's when it was first produced. We have beer made in three locations. We have it in 7,000 BCE in China, then 7,000 BCE in Iran, and then 3,500 BC in Egypt. Those are all listed here. Cheese was first made in 5,500 BCE in Poland. So again, some of these products are the result of microorganisms. Acetone is a very important chemical here. It was made by the first president of Israel, Chaim Weizmann, and he was a biochemist. He was looking over a shortage of acetone during World War II, and what they used it for in in World War I, my apologies. In World War I, Britain had a shortage of the acetone needed to produce cordite, which is a propellant for ammunition. So therefore, they wanted to use Clostridium acetobutylacum. This organism here, this is a Clostridium species, and they're going to use a feedstock of maize and chestnuts in order to grow these organisms, and then we're going to harvest the acetone for the cordite in World War I. Again, that's World War I in Britain, not World War II. There are two phases in what's known as fermentation or acetone butanol ethanol fermentation. So we got the acronym ABE. There's two phases again. So first we have a variety of organic acids produced. We're going to make ATP. And then we're going to convert those acids into alcohols such as ethanol and butanol. And then we're also going to make acetone, which is seen below here. Again, we're going to also be using glycolysis. The organisms will be using glycolysis, and we're going to just harness that for that first phase. Penicillin is another famous product in Applied Micro. Again, it was discovered by Fleming in 1928. They're going to be using deep tank fermentation by Pfizer, and they're going to be using these tanks also for citric acid production. There is a shortage in the penicillin, so they didn't have enough for clinical trials at the time. However, when they moved it to the US in 1941, they were able to find a new strain from a cantaloupe in Peoria Market. During World War II, they moved the penicillin project here to the US to keep it out of the Axis powers. And therefore, after this development, when they found the new strain and they started using deep tank fermentation, there's enough for D-Day, so then there are less chances of infection when the soldiers get wounded. These are just some products that the microbes that he listed out. Okay, so polysaccharides, we have xanthan. Xanthan gum is made by Xanthomonas campestris, sorry about that. It's used in drilling mud toothpaste and salad dressing. So again, xanthan gum is from Xanthomonas campestris, and it's used in salad dressing. Dextrin, this is another polysaccharide. This is from Leuconostoc mesenteroids. Leuconostoc mesenteroids. It's used in Safadix eye drops as well as intravenous solutions. A third polysaccharide is alginate. This is from Pseudomonas aeruginosa. That's the bacteria that they're going to be producing like a blue-green pigment. Alginate is used in ice cream, paper, and paint, as listed here. Right now we're going to go into acids. So we have citric acid, which is made from Aspergillus niger. This is a food acidulant. This is for sour foods, so that very sour taste in candies is from this Aspergillus niger's product of citric acid. We also have acetic acid. Again, that's a preservative. That's from Acetobacter or Gluconobacter. And lactic acid is from the Lactobacillus species. This is a preservative, a curing, and a flavoring agent. So we have 3 acids here. Again, citric is for sour. This is from Aspergillus. Acetic acid is from Acetobacter. Again, in the name, acetic acid and then Acetobacter. And also from Gluconobacter. Lactic, we have it from Lactobacillus. Again, lacto in that genus name implies that it has something to do with lactic acid. Then that's used for curing and flavoring. Beta amylase, which is an enzyme. These are all going to be enzymes now. Gotta mark that. We have beta amylase, and this breaks down starch in a biochem pathway. But we're not talking about biochem right now. We're talking about applied micro. So beta amylase is from Bacillus and Streptomyces, not Streptococcus, but Streptomyces. It is used as a sweetener. Protease, again, breaking down proteins with protease. That's going to come from Aspergillus. So Aspergillus, again, we just saw citric acid come from Aspergillus. This one's also going to come from here. Protease is going to be used in detergent, food industry, and pharmaceuticals. We'll also get it from Streptomyces as well. That's why the S is there. Protease is also harvested from Streptomyces. Pectinase A is also from the Aspergillus. Pectinases are going to be used in fruit juice clarification. What does that mean? So when we clarify a fruit juice using the pectinase from Aspergillus niger, we're going to have a decrease in clumps. Rennin, which is from the Mucor species, this is a milk protein coagulate. So another enzyme there. Very interesting. Okay, now let's go to the vitamins. Again, we have some commensal bacteria in our gut that make vitamins for us to use that we can't synthesize on our own. This is kind of separate. I'm not really sure on the top of my head if any of those are the ones that gut bacteria are making. However, the ones that are listed in Applied Micro are B12. These are made by Pseudomonas and Propionibacterium. Again, supplement. All of these are going to be supplements. Riboflavin is going to be made by Ashba gossypi. We're going to gossip about the riboflavin. Ashba gossypi is a species or the organism that makes it. Carotene is going to be made by Blakeslea trispora. It's also going to be not just a supplement but also used in animal feed. Then we also have L-ascorbic acid. This is from Erwinia and Corneobacterium species. Corneobacterium, let's talk about this one. This is the palisade bacteria, so the L-ascorbic acid comes from this bacteria that likes to arrange itself in these palisades, like that. Alright, let's talk about amino acids that are made in Applied Micro. We have glutamic acid. This is going to be from Corneobacterium, again, a Corneobacterium glutamicum. This is going to be a flavor enhancer. This is the monosodium glutamate, the king of flavor. This is what makes glutamate, aka MSG. It's a component of MSG, glutamic acid. That's, again, the king of flavor. So we have a Corneobacterium to thank for that. L-lysine is also made by Corynebacterium glutanicum. This is again a supplement and an animal feed. Our last amino acid is L-tryptophan. This is going to be made by Bacillus subtilis, so that's going to be different. It's an antidepressant. We have a ton of antibiotics that are made by the organisms. We have streptomycin, made by Streptomyces. This is an aminoglycoside. We have erythromycin. This is Streptomyces erythraeus, and this is a marcolide. So erythraeus, that's a species, but it's still a Streptomyces. I might flashcard these because there's just a ton of them. They're all marked with a little icon too, so that's kind of scary. Tetracycline is going to be made by another Streptomyces called Viridifasciens, and a tetracycline is a quinone. Penicillin, of course, is Penicillium chrysogenum. I'm going to write that down. Chrysogenum, and this type is the beta-lactam ring antibiotic. Just highlight. That looks very messy. All right, food. We kind of talked about food earlier. So bread is made by the Saccharomyces cerevisiae, the yeast. We're going to have products such as white bread, rye, and wheat. Alcohol is made by, again, Saccharomyces, more yeast. Beer, wine, and spirits. Cheese is made by Lactococcus this time, not Lactobacillus, so I'm going to have to erase that. Lactococcus is cheese, yogurt, and sausage. Oh, wait, I have that wrong. So Lactococcus is cheese and yogurt. Sausage is Bacillus. Sorry about that. Once again, cheese and yogurt are also Streptococcus, so that's also strep. Lactococcus goes only to cheese, and then yogurt and sausage are Lactobacillus. Chocolate is made by yeast and lactic acid and acetic acid bacteria. If we go back up here, we do have some lactic acid bacteria here. This is a Lactobacillus, and then citric acid. It's not a bacteria. We have here the Aspergillus niger. It says bacteria there, so I'm going to just go with bacteria. All right, and I think that's all of the slides that are marked with that little icon. So I think that's where we're going to stop for this intro. Everything else down here is just it's just, background information on the intro slides that aren't marked. So yeah, thanks so much for tuning in. Please do something nice for someone. Take care.